You may have seen it up on a wall, on the side of a coffee mug, or maybe you've heard a song about it. But why is there so much fuss over the periodic table? Well, it does nicely catalog all known elements, but as if that wasn't accomplishment enough, it can teach us a lot about how they behave. The periodic table is all about not only the elements, but their relationships. This allows scientists to know elements' properties, in some cases even before their discoveries. The table is organized in groups and periods. Periods go horizontally, while groups go vertically. There are currently 7 periods and 18 groups, although some ignore transition metals, resulting in 8 groups instead. This is where the periodic table begins to show its greatness. Across groups and periods, elements start showing trends. The atomic radius increases down a group but decreases across a period, while both ionization energy and electronegativity do the opposite. The ionic radius, similar to the atomic radius, also increases down a group. Groups can also help show valency, or the number of electrons that need to be removed or added to have a full outer shell. This means elements will have greater valency towards the middle, ignoring the noble gases since they already have full outer shells. All of the elements in the same group have the same number of valence electrons. Another feature of the periodic table is how it shows different electron orbitals. In an electron shell, there are different possible orbitals. In order, they are the s orbital, the p orbital, the d orbital, and the f orbital. The table shows which orbital the last electron of an element would be in. These are called blocks, and every orbital has one. The s block comprises of the elements in group 1, which are hydrogen plus the alkali metals, group 2, the alkaline earth metals, and helium. Following the s block is the p block. This contains group 13, the boron group, group 14, the carbon group, group 15, the nitrogen group, group 16, the oxygen group, group 17, the halogens, and group 18, the noble gases, with the exception of helium, which, as you remember, is part of the s block. The d block contains groups 3 through 12, collectively known as the transition metals. The only elements part of the d block which are not transition metals are lutetium, which is part of the lanthanides, and lutetium, part of the actinides. The f block contains the remaining of the lanthanides and actinides. The lanthanides are those elements in group 6 between the alkaline earth metals and the transition metals, from number 57, lanthanum, to 71, lutetium, while the actinides are right below the lanthanides, covering the atomic numbers from 89, actinium, and 103, lawrencium. So, maybe the next time you see the periodic table up on the wall of your science class, you can see the genius that it hides in plain sight.